Okay, fifth years, this is just for you to work independently until Friday's lesson. So we're going to carry on with combustion. We're going to just do a little bit of revision of complete combustion. We're going to do balanced chemical equations for incomplete combustion. We're going to then talk about how you can tell from the flame color, how you describe sort of when you observe combustion, the different colors of flame and what it means. And lastly, we're going to talk about the products of combustion and testing them and the effects of them. So hopefully we get all that done. So as I say, with this video, I'll be working through everything, but, and pause when I tell you to pause to do a question, and then you can sort of just switch it on to get the answer. You don't have to watch me working through everything unless you need to. So with that in mind, have a go at this first equation and pause the video while you do that. I'll be carrying on with it and working it out. Okay, so you've got, I've written out, remember that it's water, carbon dioxide, that should be O2, oxygen, water, and carbon dioxide, you should know the formulas of, and then ethanol, that's one you need to know. So C2H5OH. Right, so first thing, balancing, and I'm using different colors just so you know. So first thing is your number of carbons, gives you a number of carbon dioxides, your number of hydrogens, which is 6, gives you half that to get the number of water. And then the last bit, the tricky bit, is balancing your oxygen. So over here, you've got 4 plus 3, you've got 7 oxygens. And over here, you already have 1 oxygen, so you need 6, right, to get 7. So that means you divide that, so you'll need 3 O2s. Or you can think of it this way. So the number of O2 is equal to the number of oxygens on minus 1 on the right-hand side divided by 2. So just having a look at the notes so far, right? So there's examples of balanced chemical equations there and for complete combustion. Now, in complete combustion, you have a limited supply of air. You would have to be told that they were the conditions, right, in an equation. You would have to be told you have a limited supply of air or oxygen, right? Obviously, oxygen makes up about 20% of the air. And this time you get carbon monoxide and water. Now, they're the chemical equations you have to do. You also need to know that you can get soot, all right? So if you were to name the products of incomplete combustion, you would say carbon monoxide, water, and soot. You can name any of those, whereas the chemical equation will just include carbon monoxide and and water. So how does that work? So this actually works in exactly the same way as the complete combustion. The only difference you're going to have here is that your formula of carbon monoxide is CO, but the balancing, the way that you balance it, doing your carbons to carbon monoxides, your hydrogens to give water, and then counting your oxygens to balance O2s will be exactly the same. So let's have a look at an example. So supposing you had a question asking you to write an equation for the incomplete combustion of butane, right? You would start with reacting butane plus oxygen gives you carbon monoxide plus water. Right, now, then like the last time, you would fill in for the balanced chemical equation, fill in the formulas that you know, and you'd need to learn carbon monoxide is CO. It's in the name, mono meaning 1. So carbon dioxide, 2 oxygens, dioxide, carbon monoxide, 1 oxygen, right? Now butane then, it's an alkane, so it's got 4 carbons and then CnH2n plus 2. So you're going to have 8 plus 2, so 10 hydrogens, right? So the molecular formula of butane is that. Okay, so let's go at balancing it. So if 4 carbons means we're going to have 4 carbon monoxides, right? So that's exactly the same method of balancing. It's exactly the same. Just have to bear in mind your different product. You've got 10 hydrogens. So you half that to get your waters. And lastly, our oxygens, and that's where the thinking has to come in. So the total oxygen over here is equal to, and now this time it's actually, you can add your numbers together. So remember, for your carbon dioxide, you kind of had to keep an eye on it, but actually now you can just add your mole ratios, those ratios together, and get 9. And then over here, the total O2 is going to be half that. So it's 9 over 2. So it's 4.5. Okay, so I'm going to work through another one. If you feel comfortable with doing it yourself, just pause the video and just check my answer. So I'm going to work through 2 of these. And again, if you want to have a go at them yourself, and you can just fast forward to the end, you can fast forward through and get to where the answer is to check. But I'm going to work through it slowly here. So let's have a look. Incomplete combustion of these substances. So propene. So again, we're going to write the word equation. So you're going to get carbon monoxide and water. So we do the word equation first. And the chemical equation. So we're going to just put in our formulas. And propene, right, it's an alkene, it's got 3 carbons. Prop means 3. CnH2n, so you've doubled the number of hydrogens as you have carbon, and that's the chemical formula. Now the balancing, so we've 3 carbons, so that means 3 carbon monoxides. We've got 6 hydrogens, which you half that to get the waters, so you have 3 waters, and finally our oxygens. So as I say, in this instance, you can just add those together. So you have 6 oxygens, and then you have 6 over 2 oxygen molecules, 6 oxygen atoms, 6 O2 molecules, which is 3. So that's it balanced. Okay, going to do the same with propanol, propan 2-ol, but as I say, the molecular formula of propan 1-ol and propan 2-ol are exactly the same. So again, let's write the word equation. You're always balancing, you're always working with oxygen, reacting with oxygen, whether it's complete or incomplete combustion. And just remember that your complete combustion is when you have a plentiful supply of air or oxygen, and incomplete combustion is when you have a limited supply of air or oxygen. Right, so again, I'm going to put in my formulas. Propan 2-ol, so prop, C3. The hydrogens will be 2n plus 1, so that's 7. And then the OH for the functional group, the hydroxy functional group, or the alcohol functional group. Okay, so now again, this time, remember, if you have an alcohol, it's only the oxygen where you have to sort of pay attention. So 3 carbons, 3 carbon monoxides, total of 8 hydrogens. I'll just change the color there. 8 hydrogens, so you half that. You'll have 4 H2O. And last, your oxygen. So again, you've got 7 oxygens. So now remember, you have to subtract 1. So you're going to have 7 minus 1, half of that, O2 molecules, right, to account for the oxygen you already have. So that's equal to, it's almost 3. Okay. So that's that balanced. At this point, I'd like you to try some of the questions from the notes. They are question 73 and 74, which is on page 15 of your notes. So I'd like you to do those. Pause the video, do them, and then start the video again to get the answers, which should pop up as soon as you continue playing. Okay, so fair bit of work in that. So the first set of reactions here are the complete combustion. So just watch, you decane and nonane. So that was a bit of a trick one there because it was 20 hydrogens. So you take 2 away and divide by 2. So it was C9H20. So just in case you didn't get that, I wouldn't worry too much about it. So that's your balanced equations. And then the incomplete combustion on the next page. So again, you have CO instead of CO2. So you're going to have less oxygen. Now, you'll probably notice that there's a bit of a pattern here. So as you go up, you had added 1.5 each time. So there will be a pattern if you saw them all. It's not of much use to you, I have to say, but there will be a mathematical pattern of the ratios as you go. Okay, so you added 1 each time here. All right, now, and 75, the exothermic means heat is released. Now, I'm going to just deal with the whole doubling thing that Andrew brought up today. And thank you, Andrew, it was excellent work. and everyone. So you've got, right, let's have a look at ethane here. So I'm just going to pause and go on to. So the balanced chemical equation for, say, ethane, the incomplete combustion of ethane is here. So you've got 3.5 O2. Now, these are mole ratios, right? So if you have whatever number of ethane you have, you need 3.5 times that number of oxygen molecules for it to completely react. And you'll get 2 carbon dioxide molecules for every one of these, and 3 water molecules for every one of those, right? So that was stuff we did last year, yonks ago, and we have to do it again very soon. But you may, and you will see in books sometimes that they tend to get rid of the halves. You do not have to, right? It is fine to write 3.5 here. It is completely correct. It's not a problem. It just, but you will see sometimes this just that, you double the entire equation in order to just get rid of the half. There's no need to, but you will see it. You'll see it in the revision book and some other sources as well. So all you do is double every number. So you can just, because you end up with the same ratio anyway, right? Whether you double it or not, it doesn't make any sense, obviously, to triple it, because then you're going to get weird, you're going to get your half back. But yes, you can get rid of halves here if you want, but you do not have to. But it is correct. Either of those is correct. Okay, we're going to move on to something easier but learny, right? Is how do you tell? How can you tell whether, like if you're burning, right, combustion of a particular organic compound, how can you tell that you've got like an alkane, an alkene, or an alcohol? And the truth is, you can't tell very easily, but there are some features of them that are a bit of a giveaway. So you have here the alkanes and alkenes burn with an orange sooty flame, and alcohols burn with a blue flame. So I'm just going to show you this. I've got some pictures in the interweb. Right, so this is methanol. Okay, so it burns with a blue flame, right? Ethanol, so we'll pretend that any alcohol will do that. Right. It's really, let's not go there. Right, it blue flame. And you can see it there. It's kind of like, I think the Bunsen burner is the closest you've probably seen to this. When you have the hole fully open in the Bunsen burner and you get a blue flame, that's actually because it's pure, it's complete combustion. You're allowing air in, you have a plentiful supply of air, and you'll have a blue flame whenever there's kind of clean burning. It's complete combustion. But methanol, because it will burn with blue flame. Now here you have actually, this is an alkane, and this is an alkene. And this one here is probably the better sort of thing to look at. So you've got your soot, right, the sooty flame, right? So that's your bits of carbon. Remember, carbon is produced during incomplete combustion. So that's particles of carbon. And then you have an orange flame. You'll know it kind of what you probably consider when you think of burning is an orange flame, right? Or yellow. Well, we'll call it orange. Hexane, you'd have the same. It might not be as sooty as the alkene, but anyway. So they're the colours of flames that you get. Okay, so apart from the flame colour, to give us an idea of what sort of substance we have, we can also sort of test the products of combustion. Now, remember, right, that you have complete and incomplete combustion. And the products are slightly different. Okay, so for complete combustion and incomplete, you're going to get water for both of them, right? Complete combustion will give you carbon dioxide. Incomplete will give you carbon monoxide and also carbon, right? Which we don't include in chemical equations. Now, there's tests for just a couple of these, right? So you can test for that and not those. All right, so there's a chemical test for those two, but not the carbon monoxide or soot. And the test is something you will obviously remember hugely because we did it last year, and remember everything we did last year, right? So this is the test. So maybe pause for a minute and think, can you remember how to test the products of combustion? How do you test for carbon dioxide? How do you test for water? So this is the test for carbon dioxide and the test for water. Right, and just try and think what substances are used to test. All right, so if you want to pause and think about it or just play on, that's up to you. Okay, so it's Lime water is the substance, right, which is calcium hydroxide. And it turns milky. So you bubble carbon dioxide through it and it turns milky. All right, and that water test, what you've got here, the white stuff here, is anhydrous copper 2 sulfate. And what happens is if you add water to it, it's white substance. You add water, it turns blue. Right, so that's what that's trying to show. So the top stuff here, the blue stuff is the hydrated copper 2 sulfate. Now, just to see how you got on with that, I want you to attempt questions 81 to 83. I'm going to work on, you pause the video and do the answers and then check my answers against yours. So the products of the reaction, right? So lime water test for CO2. Okay, so the lime water will turn milky. What substance is used to show that water formed? Okay, so that is anhydrous copper 2 sulfate, or you can just write the formula, and it turns from white to blue. Right, so that's, you name the substance and you have the observation. So there's 2 bits to that question. 83, what colour flame is observed? Butane, so that's going to be orange sooty. So it's an alkane or an alkene, it's going to orange sooty flame. That's also an alkene, so orange sooty flame. Ethanol is an alcohol, so it's going to be a blue flame. And propan-2-ol will also be a blue flame. Okay, so it just depends on the functional group. So alkanes and alkenes will give you an orange sooty flame. Alcohols will give you a blue flame. So for the last part of the lesson, we're going to sort of just summarize the information in this. So this is about carbon monoxide and also about atmospheric pollution of various substances. So I think the best thing to do is gather the information into a table, and I'll start it off for you. So write a little table, and I would put it in my notes if I were you, just beside the notes here or wherever you're going to see it again. Okay, so we're going to do a table, and I apologise for no ruler. I haven't worked out how to do a straight line on this yoke yet. So you obviously will use straight lines and rulers and pencils and stuff. Okay, so what I want you to do is I want you to list the substance, right? So whatever the pollutant is or the issue with it, right? What's the problem with it? And then what it causes, what it causes. Okay, so I'm going to go through each of them now, but I want you to finish them. I'll do just bits and pieces, and I want you to finish it yourself. So the substances are carbon dioxide, carbon monoxide, carbon, and sulfur. Right, so if you let's look back at the notes. So you've got carbon monoxide in this first bit, and then here you've got, carbon dioxide, carbon monoxide, soot, and sulfur impurities. Let's just call it sulfur, that'll do. So the next thing is, what is the effect of them? Right, so you'll see that there's actually most of the information you need is in the boxes, right? So my notes are just underneath, but they're just a reworking of it. So for example, the issue with carbon dioxide is that it's a greenhouse gas. Okay, and then what happens is, if you look in the notes, you've got, so I would just lift directly out of this. So it causes sea level rises, flooding, and climate change. So add that to, sea level rises, flooding, and climate change. Okay, so I want you to work through that yourselves, right? I'm going to, again, finish this table. So do it yourselves. Use the information in the notes to put the table together, please resist just copying it out. Have a read of the notes and complete the table yourself. And when you're happy that you've completed it, then you can check what I've written. And it might be slightly different, but that's okay. So pause and complete this yourself using the notes. Sorry, folks, I shouldn't have let that play while I was finishing that. Okay, so once you've that done, lesson is over. Thank you very much. Well done with the work.